Hi, so I'm going to start off with Chapter 6, the atmosphere and the oceans, and just going to start off with what I learned. The first thing is the heating and cooling of Earth's surface are accomplished by energy changes by the atmosphere and the oceans. Another thing is initial sources of energy come from solar radiation. Gains and losses in heat to keep the Earth at the right temperature is called heat budget. Land and sea respond differently to solar radiation. Land has low heat capacity while the ocean's heat capacity is very high. The density of air is controlled by three things, and they are temperature, the amount of water vapor in the air, and the altitude. There are three active reservoirs for carbon dioxide, and they are the atmosphere, the oceans, and the terrestrial system. The atmospheric pressure is the force with which a column of overlying air presses on an area of Earth's surface. Some things I found interesting in this chapter are solar radiation has the greatest intensity at the equator. The sun is so far away from Earth, its rays are parallel when they finally reach Earth. Earth takes in as much heat as it radiates back into space. The ocean stores the largest amount of carbon dioxide, and the atmosphere has the smallest amount. Earth and its atmosphere is warmed by the greenhouse effect. The average atmospheric pressure at sea level is 1013.25 millibars. Hurricanes cannot form at the equator. And moving on to Chapter 7, some things that I learned are only a thin surface layer at the ocean is heated directly because of how rapidly solar radiation is absorbed. There are three temperature layers, and they are the surface mix layer, which is the top one. The middle one is the thermocline layer, and the last one is the deep water layer. Variations in temperature, salinity, and pressure combine to control the density of seawater. The density of seawater is measured in grams per cubic centimeter. Temperature and salinity define a water type. There are numerous amounts of specific currents for each ocean. And to start off with the Pacific Ocean, some currents are North Equatorial Current, Alaska Current, and North Pacific Drift. For the Atlantic Ocean, there is the Gulf Stream Current, the Canary Current, and Brazil Current. For the Indian Ocean, there is the West Australia Current and the Equatorial Countercurrent. And to move on, major ocean currents transport enormous volumes of water. The largest current is the Antarctic Circumpolar Current. Eddies are pockets of water moving within a circular motion. Large and small eddies exist all throughout the ocean. To move on to some things that I found interesting in Chapter 7 are nearly half of the total solar energy at the sea surface is absorbed within 10 centimeters of the surface. If there is higher density water on top of low density water, then that water column is considered unstable. If it's the opposite, then the water column would be considered stable. Downdwelling is a mechanism that transports oxygen-rich surface water to depth where it is needed for deep-living animals to survive. The major surface currents in the ocean are driven primarily by the trade winds. There are 5 major zones of convergence, and they are the tropical convergence. There are 2 subtropical convergences, and the Arctic convergence, and the last one is the Antarctic convergence. And then on the other hand, there are 3 major divergent zones, and one of them is the Antarctic divergent, and there are 2 tropical divergences. And 3 questions I had for these 2 chapters that we went over are: can space take an infinite amount of heat from what Earth gives off it from the solar radiation? The second is, measurements are needed? What measurements are needed to define a current? And my last question I had is, why don't more factors contribute to the density of seawater?